Alright, last video we derived the 8 fundamental identities, and this example I want to concentrate on a particular Pythagorean identity that we tend to use a lot in our trig calculations, and it's the first one we derived, that the square of the sine value plus the square of the cosine value equals 1. I want you to notice that you can write this in two additional ways. You could note that the square of the sine value is 1 minus the square of the cosine value. Or you could write that the square of the cosine value is 1 minus the square of the sine value with your algebra skills. Okay, so all of the identities can be manipulated algebraically in a manner like this. The problem that I want you to solve is assume that 3 sine squared of x minus 2 cosine squared of x equals 1, and find the numerical value of sine squared of x. So that means we want to end up with sine squared of x equals a number. And right now your equation contains not only sine squared but also cosine squared. So in an algebra setting, the best thing for you to do would be to find a relationship for cosine squared that links back to sine squared. And we have one here. We have the relationship that cosine squared of x can be replaced with 1 minus sine squared of x. Okay, now since we're after solving for sine squared, we're going to apply our algebra knowledge, distribute and collect like terms. And we can see that we could collect these into 5 sine squared x. Move the 2 to the other side would equal 3. So sine squared x would actually equal the value 3/5. And stop here because you notice that that's all you were asked to give was the value of sine squared. So you're done.